What makes my phone go from this to this? And what prevents everyone else in the world from unlocking my phone? Face ID is one of the world's most intriguing undertakings. Something we all interact with multiple times a day, triggered by a swift glance of something we all have, a face. It is so miraculously effortless that we often overlook its prowess. If you really think about it, this piece of security-first technology is the backbone of almost everything we do on our phones, serving as the ultimate biometric to unlock our digital lives. My phone has been with me through it all. Runny nose, puffy eyes, and the, let's be honest, frequent teenage breakout. It is smart and can recover from imperfections. Every time I open my phone, it snaps a picture to add to the wall, which all phones collectively learn and magically improve from. But does that mean my face, and therefore super sensitive data, is broadcasted to the network of iPhones across the world? Also no. Put simply, machine learning is an algorithm that gets smarter when it looks at data and gets experiences of its own. From image and speech recognition to algorithmic trading to the chess robot that you just can't seem to beat, ML relies on a model that imitates the way that humans learn, continually harvesting data to improve performance. However, with such an emphasis on data, especially if our phones were to snap a picture every single time we decided to unlock it, many people would not be happy. Accessing private and sensitive user data in any centralized place is problematic. So then, how can we improve models without sacrificing privacy? The manner in which we collect this data is very much separated on edge devices, which is the tether from real-world raw data to a central location. The advantage of these hybrid devices is that data is essentially limitless. As long as this decentralized data never leaves your device, privacy is actually not compromised. In the case of federated learning, we use on-device data to train models locally. Then only updates in local models are shared with a central model, which is immediately averaged with other user updates to improve the model. When Face ID started detecting users in face masks, it could not interpret what it was seeing. As updates in local models began permeating the central model, the model repeatedly learned and adapted to unlock using just our eyes, providing universal improvement on each of our devices. Federated learning has decoupled the ability to do ML from the need to store data in a cloud. It has reduced computation costs by minimizing the communication needed between servers and workers, and this has really only started to become possible as AI chips are now being planted in our phones. Still, leaps and bounds are to come in this nascent field. Currently, federated learning is implemented in our phones to help us predict what we might type or what we might request. Imagine it could automate all of your daily habits, sorting emails, bringing you to relevant headlines, and finding shortcuts through menial parts of your day. What if this was implanted in smartwatches, autonomous vehicles, hospital equipment, and other data collecting edge devices? What if there was no central model at all? If this is a question you're itching to answer, gossip learning might be your next adventure. So let's face it, federated learning has enormous potential to change the world. It's only a matter of time, data, and you to unlock it.